Hello everyone, welcome to Energy Conversion 2 class. Today we will start with chapter 5, that is Commutator Motor. So, first of all, coming to AC series motor or universal motor. So, first of all, the construction of AC series motor is as like as DC series motor. If a DC series motor is connected to an AC supply, it will rotate and produce unidirectional torque because the current flowing in both the armature and field reverses at the same time. So, when a DC series motor operates on a single phase supply, then it is called an AC series motor. So, the universal motor is a type of electric motor that can operate on either AC or DC power and uses an electromagnet as its stator or to create its magnetic field. It is commutated series wound motor where the starter's field coils are connected in series with the rotor windings through a commutator. That is why it is known as commutator motor. So, here you can see the diagram. This is the AC or DC supply. This is the poles. This is the rotor. This is the stator. We have stator poles, north pole and south pole, and AC supply is given to the stator, and here is the rotor connected. We can see the rotor conductors. These are the brushes. So, the performance of this type of motor will not be satisfactory due to the following reasons. So, the reasons are, firstly, the alternating flux would cause excessive eddy current loss in the yoke and the field core will become extremely heated. Due to this extremely heat produced, the motor operation is not satisfactory. Second, sparking will occur at brushes because of huge voltage and current induced in the short-circuited armature coil during the commutation period. 3. Power factor is very low. Due to the above drawbacks, DC series motor required some changes by which AC supply input disadvantages solved. The changes to the commutator motor that are made are, first, the entire magnetic circuit is laminated in order to reduce the eddy current losses. Secondly, a high field flux is obtained by using a low reluctance magnetic circuit. Next, excessive sparking eliminated by using high resistance leads to connect the coil to the commutator segment. Though this type of motor can be operated either on AC or DC supply, the resulting torque speed curve is same. It is also known as universal motor operation when it is connected to an AC supply. The same electric current flows through the field and armature winding, and the field winding produces an alternating flux that reacts with an armature current to produce a torque, and the direction of the torque is always same because both current and flux reverses simultaneously. Now coming to characteristic of universal motor. The speed increases to high value with a decreasing load. So we can say if the load into a AC motor or universal motor is decreased, then its speed will increase to a high value. Note it down. Secondly, it has very high starting torque. Remember, the universal motor has very high starting torque. And also, at full load, the power factor is 90%. When the universal motor is in full load condition, we can say, then its power factor cos-phi is 90%, or we can say power factor is high when the motor is at full load condition. Now coming to speed load characteristic of universal motor. The speed load characteristics of a universal motor is similar to that of DC series motor. The speed of a universal motor is low at full load and very high at no load. Usually, gear trains are used to get the required speed on required load. Here we can see clearly the speed load characteristic of a universal motor or an AC series motor. This is the x-axis, this is the y-axis. In the x-axis we have taken percentage full load torque. In the y-axis we have taken percentage full load speed. So as the name indicates, this is the graph between speed and torque. So this is percentage full load. As load increases, this speed will be likely decreasing. See, this is for direct current, this is for alternating current. For a high value of loading, the speed will be less, and for less value of loading, the speed will be high. Here you can see. Now, the uses of AC series motor or universal motor. Different uses of universal motor as this universal motor can be used in sewing machines. Secondly, in vacuum cleaners, in mixer grinders and blenders we can also say. The universal motor can also be used in high-speed vacuum cleaners and also in hair dryers, power saw, drilling, electric shaver, etc. Now, single phase repulsion motor. A repulsion motor is a type of electric motor which runs on alternating current. It was formerly used as a traction motor for electric trains but has been surpassed by other types of motors. Now, repulsion motors are classified under single-phase motors. We can also say that a repulsion motor is similar to an AC series motor except some modifications. Now, the brushes are not connected to supply but are short-circuited by themselves only in case of your repulsion motor. Also, we can say that the current induced in the armature conductor by mutual induction method. So, here the stator is there, rotor is there, and the armature conductor will induce current in it by the process of mutual induction method. Thank you.